Today our objective is going to be, and I've written it up here, I'm going to get kind of, oops, sorry. Our objective today is we're going to understand, we've got a lot of vocab. Relative frequency. Marginal relative frequency. And joint relative frequency. And conditional relative frequency. So we're going to understand, and then we're going to calculate the above types of frequency. So we're going to actually do some math today. I know, how terrible in a math class. Okay, now I am going to underline one of these, and that's the conditional relative frequency. And it turned out with first period that we decided not to push into that idea, that there was enough that we talked about today, that we'll talk about the conditional relative frequency tomorrow. Okay? All right, so what I'm going to do is I'm going to give us an example two-way frequency, like what we've talked about the last 2 days, and then I'm going to show you how we morph it into a two-way relative frequency. And then from there, we're going to come up with definitions to the first three vocab words, which are relative frequency, marginal relative frequency, and joint relative frequency. Does that make sense? Okay. So let me sketch over to the next page. And what we're going to talk about is looking at boys versus girls and who plays video games or not. Okay, so those are going to be our two categorical variables. So we've got gender. Oops, go back to black. Gender. We've got play video games. We're going to have, let's see, girl, boy, and total. And then we're going to have yes, no, and total. Okay, so this survey was completed with 100 students being asked, and remember that total number of students surveyed is going to go in that bottom right-hand corner, okay? So for the girls, we had 34 of them said yes, we play video games. We had 19 of them that said no, we do not. That gave us a total of 53 girls that they surveyed. For the boys, we had 38 of them said that they play video games. Only 9 of them did not, for a grand total of 47 boys who they surveyed. That gave us a total of 72 students from the survey who said yes, and 28 who said no, we don't play. Okay, so this is what we've been working with the last couple days, is just raw data, and that's all that these two-way frequency tables give us is raw data. But what we're interested in is what kind of relationships can we find? And I emphasize that word relationships because if you looked at the words that we're trying to define, we've got relative frequency, marginal relative frequency, joint relative frequency. So let's start off and let's give a definition to what on earth do I mean by relative frequency. And relative frequency just deals with how the data relates to each other. So instead of thinking about it being, a family member, it's how are they related to you? Race, we're taking notes, bud. And depending upon what pieces of data we relate together determines whether we're talking about a joint relative frequency or a marginal relative frequency. Okay, so let's just talk about relative frequency to how many kids were surveyed. Now, we're really lucky that in this particular one that we have 100 students that were surveyed. So what we could do for relative frequency is see how the number of girls who play video games relates to how many students played. So what a lot of people would do was rewrite that as a fraction. So for the girls who play video games, we could say that 34 out of 100 play video games. We could change that answer to a decimal. What would that be? We'd say 0.34 of the girls surveyed played video games compared to everybody. And then how would I write that as a percent? Lexi? Yeah, we move the decimal to the right twice, 34, and add the percent symbol. So what we're going to start looking at is not the actual raw data, but now we're going to look at how it relates to different things. So if I wanted to relate it back to the total number of people in the survey, this one would be super simple. So the girls would be 34%. What would we write for the girls who don't play video games? How do they compare to the whole group that was asked? Trent? Say again? 19. So it'd be 19 over 100, which we could write as 0.19, that we could write as 19%. Well, how about the number of boys who say, yeah, we play video games? What would they get? Armand? 38%. We could say, 38%. 38 over 100, 0.38, 38%. And then what about the number of boys who didn't play video games? What would we say about them? What would be their relative frequency to the kids that were in the survey? Finn? 9 over 100. Yeah, they'd be 9 over 100, which would be the same as 9/10, which would be the same as 9%. And then we could say, okay, well, how many of the girls in the survey were actually, or how many people in the survey were girls? So if you look over here, we have 53 out of 100, which is the same as saying 53%. And for the first time in all these charts we've been doing, do you see what I'm seeing? They finally have a survey where there were more girls than boys. And funny enough, it was about video games. I think that is the weirdest combination. I would have thought you would have had way more boys surveying, because this seems to be more of a boy thing than it is a girl thing. Not saying girls don't play video games. They do. Okay. Now, for the total number of people who said yes, oh my gosh, it was a whopping 72%, 72 out of 100. It was a very low 28% who said, no, we don't play video games at all. Now, how would I write 100? What would I be writing for him if I wrote the answer as a decimal? This is kind of a trick question. See, Justin Pratt? I could say it's 1. It's all. It's the whole represents the whole. Okay, and these are all parts. As a percent, it would be 100% of the people there. Okay, all right. Now notice I treated all of the numbers exactly the same. I took every single individual value and compared it to how many people were surveyed. Okay, that's relative frequency. So let's reproduce this chart again. But what we're going to do now is talk about the joint relative frequency and the marginal relative frequency. So we're going to reproduce this guy again. You might want to give yourself a little bit more room. We're going to stick some stuff in with those numbers. So again, we had gender. We had, or actually, let me see. You know what? Hold on just 1 second. Let's hold off on this for 1 second. Let's go back to this. Okay. If you look at this table, what we've just done, and let's look at 9 over 100. Yeah, everybody see where 9 over 100 is? So what could we say 9 over 100 represents? Okay, Penny? No, what does it actually represent from the chart? Not what does that number represent, but what does that value represent? Okay, again, you're just giving me another way of saying the same thing. I'm saying, how does that relate back to the chart itself? Okay, Chandani. So this is 9 out of 100 boys, or 100, or 9, wait, let me try that again. Hold on, back up. 9 boys out of 100, 1,000. Whoa, that would be really bad. 100 kids surveyed don't play video games. Okay? So what we're saying is 9 out of 100 or 9% or 0.09 boys out of 100 kids surveyed do not play video games. Is this true for the whole world? No, it's just this 100 kids that they spoke to. We don't know what the number would be extrapolated. But when you're listening to statistics that you read in magazines or newspapers or whatnot, they could take this survey and then multiply it by the number of kids in the world that are below a certain age, and then they would come up with a projection. And they could say, well, maybe that is the case. Only 9% of boys don't play video games, so business people, we're going to start marketing as hard as we can to boys. We're going to make all the boy games that we want. Not to say that girls don't like playing them, but we have way more boys. So we're going to get those extra 9%. We're going to get them on board. We're going to make sure we're going to get them all there. Okay? So again, we're going to be looking at the inside and the relationship those numbers have to each other. Okay? All right, so let's go back to this task at hand. So we have gender. We have, actually, let's do a new one. This one's boring. Let's move on. Let's do, now this is kind of funny. This is in your book as well. And this deals with a girl named Kenesha. Yeah, really, Kenesha, not the singer. I thought that was kind of strange. And she decided to ask students about their preferred sport. And so we have preferred sport. And interestingly enough, she didn't choose a nice number of people to survey. She chose 80. Okay, so we can't always calculate in our heads real fast things. So under the preferred sports, the 3 choices she gave them were basketball, football, and soccer. Now, no table is complete without a total column. Under gender, we have girls, boys, and we have total. So I'm going to just share with you Kanisha's results. She found that with girls, 6 of the girls liked basketball. Actually, I'm going to move this over to the edge because we're going to add some stuff in here. So keep it kind of over to the left side. So 6 girls liked basketball. There were 12 that liked football. Interesting, 18 of them liked soccer. And there were a total of 36 girls that she had actually surveyed. And then there were 14 boys that liked basketball, 20 that liked football, 10 that liked soccer, for a grand total of 44. Up, we're back to having more boys than girls. There were a total of 20 of the people surveyed who preferred basketball, 32 that preferred football, and 28 who preferred soccer. And no matter which direction we added, we got 80 in our very end total. Okay. So, here's the fun part. Let's talk about... Yes, Lexi.
Can you show them all to fractions and then reduce them so they can do it before you can start to do all the math?
Starting with fractions is always a good way to go. I mean, the other option is to do long division, right? To take the number in the frequency box and divide it by 80, the total number of people in the survey. And you could do that to get the decimals. But a lot of these, if you do set them up as ratios and reduce them, then they become a number that you can quickly turn into a decimal, okay? So I'm going to go through this in a very particular order. And I want you, and you might want to, if you can have color codes, I'm going to use 2 different colors in this chart, okay? So if you've got the ability for that, great. So when it comes to the inside parts, what I'm going to do is I want to know how did girls fare to all of the people for each of the sports. So girls liked basketball 6 out of the 80. Now, 6 out of 80 can reduce to, they have a 2 in common, so you get 3 out of 40. But if you ended up doing, I'm going to just do division, I'm going to tell you that answer would be not a very big one, 0.075. Okay? Now for football, 12 girls chose football out of all the students who they surveyed. And again, I'm going to tell you that if you did the division, you would get 0.15. And then with the soccer, we would have 18 out of 80. And again, if you did the division, you would get 0.225. Now boys, for basketball, 14 of them chose basketball out of all the kids that asked. They were surveyed. And so that value becomes 0.175. And then for football, it would be 20 over 80. Now that's an easy one, right? That goes to 1/4, so we get 0.25. And then we had 10 over 80, which becomes 0.125. So what am I coloring that's blue? These are called joint relative frequency. And in joint relative frequency, you are dividing a row total, you're dividing a frequency that's not in the total column by how many people were in the survey. So we're going to take a 2-category answer, or value, let's say value. So for example, girl prefers basketball, so BB for basketball, and divide it by the number of people in the survey. Joint meaning 2 things together. What we joined together was girl preferring basketball. boy preferring football. Okay, that's what I mean by joint, 2 of them. And what I'm doing with relative means I'm comparing it to something else. And the comparison is always with this guy right here. Okay? All right, so that's 2 of our vocab words. What's the third one? Marginal relative frequency. Well, marginal deals with the numbers that are in the margins. So what that's left us with are the things from the total column. So now instead of looking at a girl who likes basketball, I'm looking at people who prefer basketball. So what I'm going to do for the margins, I'm going to take the total for that preference. I don't care if it's boys or girls. I'm putting them together, and I'm going to divide them by the 80. How many people were in the survey? Okay, so that's going to give me 0.25. On this one, we had a total of 32 people prefer football out of the 80 that were surveyed, and that becomes 0.4. Okay, and then we had 28 out of 80 who preferred soccer, and that number becomes 0.35. Now, how would we represent the 80 in relative terms? Okay, Anish? No. What were you thinking? Because I think you're right. It would be represented by 1 because we're looking at all the people compared to all the people. So here's the interesting thing. Look in the top row for girls. Look at the decimals we got. Oh, I forgot. I have one more bit to do. I forgot these guys over here. We can also look at the girls voting compared to the students. That number is going to give us 0.45. And then the boys voting compared to all the students. And that's going to give us 0.55. So let me go back. Go look at girls. 0.075 plus 0.15 plus 0.225. Add that up real fast and tell me what you get. .075 plus 0.15 plus 0.225. I'm going to tell you don't get 1. Add them up. What do you get? Right now. Okay, I'm looking at people staring with their mouths hanging open. You cannot add without putting a pencil on the paper, lining up decimal points, and doing the math. Do the math. All right, so Chloe, if I took the number representing the girls who preferred basketball, the number that represents the girls preferring football, the number representing the girls liking soccer, so the 0.075, 0.15, 0.225, what do they all add up to equal?
0.450.
Whoa, isn't that strange? That matches the number in the margin. Okay, that's not coinky-dink. That's supposed to happen. Just like on the bottom total row in purple, 0.25 plus 0.4 plus 0.35. Guess what that adds up to equal? 1. Okay? That's the math all works out. If the math doesn't work out, something has gone wrong. So let's put into words, what is marginal relative frequency? So we take a row total or column total, and that would be things like the number of people who preferred basketball, the number of people who preferred football. Those would be column totals. Row totals, the number of girls in the survey, the number of boys in the survey, okay? So you take the row total or the column total and divide by the number of people, not hashtag, by the way, that's a number symbol, in the survey. Okay. So here's a question based on now having done joint relative frequencies and marginal relative frequencies. I'm going to ask a question where the actual number is not in there. Okay? What percent of the boys prefer basketball or football? What percent of the boys in this survey preferred basketball or football? And how would you come about this answer? So let me go to a new screen. So, Trent, I saw your hand first. What do you think the answer would? How would I get that answer? So, boys, what percent of boys prefer basketball or football?
You add the two, like 0.25,
So it's 0.25. Oh, actually, let me go back to, we'll go to blue since that's what color it should be. 0.25. And what was the other number? No. It's not 0.25 and 0.4 because I'm asking about boys who preferred basketball, boys who preferred football.
0.175.
Yeah. So, oops. So notice that we are lining up decimal points because we're wanting to add them together. So we can put in a 0 and add. Now that answer is still not what I want it to be. I want it to be in percents. So what would the percent answer then be? Okay, Michael? So 42.5% of boys prefer basketball or football. Now, it's not saying 42.5% of all the kids, but it's 42.5% of all the boys who voted. This would be their preference. So remember, this represented the boys who preferred football, and the 0.175 would be the boys who prefer basketball. And this is now where we can start getting data that we can now communicate with other people, now that we understand this idea of joint and marginal and relative frequency. Okay?